Walmart is the largest retailer in the United States. They have revealed that they are looking for a way to optimize their revenue and predict sales for budgeting purposes. The company reached out to our analyst team to provide a solution to this problem. The main objective of our team is to use historical sales data between the year 2010 and 2012 to create a predictive model that will help forecast and ultimately optimize sales. To kickstart this project, we retrieved our dataset from Kaggle. We'll be analyzing 16 variables. Our response variable is weekly sales, and our predictor variables are the store, department, date, type, size, temperature, fill price, consumer price index, unemployment, and markdown 1 to 5. To better understand the marginal distribution of our variables, we plotted histograms of the numerical variables as seen on the screen. Having said that, my teammate Ryan will dive straight into the modeling portion of this project.
As noted, we wanted to uncover the relationship between our predictive variables, CPI, unemployment, markdowns 1 through 5, size, temperature, and our response variable, weekly sales, in order to help Walmart and their business managers optimize their sales for the stores. To do so, we started with a basic linear regression model that looked at all of our predictors regressed on weekly sales. This model produced a very low R-squared value of 0.065 and had unsatisfied error assumptions. To find out this optimal model, we moved forward with a box-Cox plot that showed us that a transformation of our Y variable, weekly sales, should be transformed by 0.22. With this, we also added an interaction term of CPI and unemployment, being as these two terms intuitively fit together, and we ran multiple stepwise functions in order to find the best model. We used AIC, BIC, and bidirectional stepwise functions to do so, and the AIC model performed the best. In this, it had the highest R-squared value of 0.107, the lowest AIC value, and the error assumptions were met nicely, as you can see in the bottom figure of this chart. The top figure is the original model we started with, and we can see the improvement as we transformed and run AIC. This leaves us with our most significant predictors and our optimal model we move forward with.
The result of our optimal model is shown in the graph below. Moving forward with our model, the model obtains a correlation between the predicted and actual weekly sales value of 0.2554 for the test set and 0.2529 for the validation set. Although the correlation seems low, the limited data set limit our ability to predict in-depth results for business. Thus, given our predictor and data, we are confident in the model's ability to predict weekly sales for business from a high-level perspective. And this model can be applied in this situation. With that, the key takeaway for business manager from our models are: first, as all other variables remain constant as CPI goes up, stores should expect lower weekly sales value. And second, markdown 1 is the main markdown session for the store, where it has strong positive impact on weekly sales. It tells the corporate and the store manager to utilize this promotional sale to increase their revenue, especially on the days in the time series graph show where sales are highest and these holidays too.
For deployment, Walmart and other retail stores in the US can use our model and data analysis for sales forecasting, targeting discounts, and predicting likelihood to purchase. First, Walmart can have an insight into weekly sales for the future, help to make business decisions, and determine their performance. Second, some of the markdown push sales to reach the peak. Therefore, in-store managers enable to determine what kind of promotion they will use to stimulate consumption. Third, we found CPI significantly impacts sales. It used to adjust consumers' income so that it determines their purchasing power, which directly impact weekly sales. However, this dataset is not perfect for optimizing sales. First, there are missing values in markdown columns, which possibly could cause bias. Second, because there's no context on each markdown column, we could not know what those markdowns are. Third, there's no data from competitors. We cannot make a horizontal comparison between retail stores in the industry. Fourth, we could find there are gaps in CPI distribution graph and unemployment graph. There could be bias or mistakes in the data.
And in conclusion, after sifting through a bunch of different models to try to find the best one, we landed on overlaying an AIC stepwise function over our linear regression model that maximized our R squared. And what this showed us, it was still a relatively low R squared value, but what this showed us is that real life is complicated, and it's really, really hard to try to predict real life sales values. But even then, we're dealing with a company that does over $500 billion in sales annually. So any predictive power, any added predictive power is going to be really, really beneficial for them in the long run. Thank you.